Do reading these words ring a bell? Take out the word quadratic and read the words systems of equations. Been there or done that sometime this year? Elimination and substitution. You can do this by graphing, but it is pretty intense to do it by graphing, what you have to do to get it all typed in your calculator. I usually don't take the time for it. If you recall back when we did systems of equations, I told you it was going to come back. Because if you remember when we did it with lines, you could do it. Substitution and elimination both worked. It didn't matter which one you used. Okay, on these it can matter. Some problems work better with elimination. Some problems work better with substitution. So you're going to get forced to one or the other of them. But in this case, we're trying to figure out all the points of intersection. So, what shape is this top equation? 2 squared subtracted. That's the hyperbola. And what's the second one? 2 squared, both positive, different coefficients. That's an ellipse. So I'm trying to figure out the intersection point of a hyperbola and an ellipse. So think about that a second. How many times could they cross? If you had a hyperbola, how many times could an ellipse intersect it? If it went across both of them, yeah, you could have 1, 2, 3, 4 points. Could it ever be more than 4? Could it be less than 4? Can it be 3? If you were tangent right at the vertex and came back, so you hit this one twice but only hit that one once, yeah, if it can hit 3, can it hit 2? Easily, if it only intercepts, well, that was bad. If it only intersects one branch, yeah, it can hit twice. Oh, it can be tangent to the vertex both times, yeah. Is it right down the middle in tangent? Okay, get 1. Sure. Where would you want it to be 1? Yeah, it'd have to be just one tangent touch. You know, obviously, it's easiest to put it at a vertex, but it wouldn't have to be. Could it be a no solution? Could it not intersect at all? Yeah. Yeah, it could be out in the middle of somewhere in the middle of one of my hyperbola branches. So you can't get a no solution on these. So realize that when we did systems of equations and we found out where 2 lines crossed, how many answers did you get? 1, unless it was infinitely many and they were the exact same line. So on these, there's a lot of different choices of how many answers you could get. But 4 is going to be the max. Okay. How are you going to know whether you should substitute or eliminate? Okay. If you do substitution, if you'll recall, you have to isolate one of the variables and then sub it into the other equation. Okay, how much fun would it be to solve for one of those variables up there? You'd have to square root it. That's going to be kind of ugly, isn't it? Okay, if the variables have the same powers on them, do elimination. So the x's are both squared, the y's are both squared, do elimination. If you have different powers going, then you'll have to substitute. So you can do it by substitution, but it just wouldn't be tons of fun. Elimination actually comes out pretty sweet. So if I want to eliminate, which looks easier? Do I want to try to get rid of the x's or get rid of the y's? Y's looks easier. So to get rid of the y's, I would like both coefficients to become a 3. Since this one's a -3, I would like the bottom one to be And hopefully you'll remember them. We just times the bottom equation by 3. So if I rewrite this, I'm rewriting the top one too. I take that all times 3. I've got 6x squared plus 3y squared equals 72. So the y's, when I add together, the y's are going to add up to 0. What do I get with the x's? 11x squared equals 44. Is that good news or bad? Yeah, that's very good, because then I can divide by 11. X squared equals 4. So then if I square root both sides, x equals what? No. Thank you, plus or minus 2. That's really big on these. Will I give you ugly ones? No. You should not get the square root of 157. They should come out decent numbers. Okay, now, am I done?
No, you got
Is that the coordinates where they intersect? No. It needs to intersect at positive 2 something and at negative 2 something. So I have to go find the y coordinate that goes with both of those. So whereas with lines, you only have to substitute it back in once to find the one answer, depending on how many answers you get here, you have to substitute each answer in to get every corresponding y coordinate. You can substitute back into either one of these. Remember, you're solving for y, so which one will be easiest to solve for y? Yeah, I'm thinking that second one looks way easier. So I'm going to copy that second one down. And we'll do positive 2 first. Okay, if I sub positive 2 into it, that's the place of x. I'm going to have 2 times 2 squared plus y squared equals 24. Thank you. So 8 plus y squared equals 24. Which means y squared equals 16. Oh, once again, nice number. Yeah. Y equals plus or minus 4. Okay, now before we go solve the other one, turn that one into coordinates. What does that mean? You just sub 2 in for x.
2 and 4 and 2 and negative.
Yeah, you just got 2 coordinates there. You just got 2, 4, and 2, negative 4. So from that one, we've got 2 answers already. And we still have to go put in negative 2. So now if I go back and I put negative 2 in that same equation, am I going to get the exact same thing? Yeah. Okay, if you're going to get the exact same thing, you don't have to work it twice. You can quit. You look puzzled. Negative 2 squared becomes positive 4. And 2 makes 8. So you still, if you see it's gonna, and a lot of times these will work out exactly the same. If you see it's gonna become the exact same thing twice, you can quit. So what coordinates do I have out of this one? So in reality, this hyperbola and ellipse intersected in 4 places. You think NASA ever worries about where things are going to intersect?
Yes.
Asteroid coming by, is it going to hit our satellite? Are they on the same path? Except they're going to do it in 3D because they got to worry about it. Yeah, it's a little more complicated. Do we? No. That's some advanced geometry. Closest I ever came to something like that. A lot of Calc 3 was 3D. But it wasn't this 3D, but it was 3D. So, there you go. That was exciting, right? So you're saying Bring on the substitution. So question, could you, if you wanted to, could you do the elimination on this one?
No, because it's all squared.
Could you get the x's or the y's to eliminate?
No.
They don't have the same powers. You got an x squared and x to the first, a y squared and a y to the first. They're not the same variable with the same power. You could not do elimination here even if you wanted to. So, okay, my other rule to you is when you're picking on substitution, you have the first thing you do is isolate a variable. So, what would be a smart variable to isolate? Okay. Would you want to pick one of the squared ones to isolate? No, because you'll have to square root it, and you'll end up with a square root of some icky quantity. It will be horrible. So, isolate a variable to the first power. Don't pick one with a second power on it. It actually might lead you into some algebra we haven't even learned yet. So, do you want to isolate the y or the x? Why did you pick the x?
Because it's by itself, you don't divide it.
Yeah. Okay, there. We could do the x, it's a 1x, we won't have to divide by anything. If I do the y, I'll have to do fractions. We'll have to divide by 2. Do you want to do fractions? So, I'm with Taylor, let's pick the x. I would just add the x over here to the left, subtract the 2y over to the right. Okay, now, even though I know you all know this, I see this all the time. Where do I go put it?
Into the other equation.
If I solve the second one,
You put it into the upper where the x.
yes, I have to go put it into the other equation. So I'm coming up here, put it in for that x. Don't put it back in the same equation you just solved. Won't work. So, okay, this one gets us into minor algebra mistakes that frustrate us. Actually, I think I want to write that in a different color for the moment. Okay. You see, I substituted that in there. Okay. On these, if we have mistakes, it's simple algebra. How do I square that? Is DJ correct? Should we spoil that? 1 minus 2y quantity squared. How do you take 1 minus 2y times itself? If you know the rule for quick for squaring a binomial, but yeah, it means you're not going to just square each one and call it good. You're going to get a 3-term trinomial. So, yeah, I would really prefer that you remember can you tell I have troubles with this? Yeah, big time. So think of it as I have 1 minus 2y times 1 minus 2y. You got to get that puppy boiled out. So what am I going to get? 1.
Minus 4y.
Okay, I'm going to do it twice so I don't lose anybody. I'm going to get 2y twice, so I guess it's going to be 4y. Plus 4y squared. Okay, that's the foiling. You still have another plus 4y squared equals 25. Because in other mistake, if you get busy foiling, you forget to write down the rest of the problem. So now add up your like terms. What you got? I try, if you will, put your squared terms up front. So 8y squared plus 1 equals 25. Oh golly gee. Haven't said you've seen one in a few days. It's a quadratic equation, isn't it? I told you they're never going away. Never. So how do you solve a quadratic equation? Negative 2y times negative 2y was 4y squared. Then I had this 4y squared. So this part was your foiling, plus you had to keep the rest of the equation. That's what I said. People forget to copy down the rest of the problem. Okay, so how do you solve a quadratic, dudes? It must be equal to 0. If I subtract 25 over, okay, you know 4 methods for solving these. Factoring formula, completing the square, or graphing. I would go for factoring. Something you can do to make life easier before you start. Well, you would take out a 4, yeah. So that would be 2y squared minus y minus 6. It'll just make your numbers easier to factor with. I'm actually going to stop it there.